Hello. I start a new series about these synth modules I design, probably 10 or 12, once a month for a year, if I manage. Hopefully I manage. My first idea was to make a series where I build like a monosynth or a synth set module by module, but it's a bit boring because there are like lots of those normal like oscillator and envelope generator and VJ modules there, and nobody's gonna like follow my lead in this order anyway, so I'll design things a bit more randomly and maybe try to make a bit more, well, not exotic, but different than usually our usual modules. Like this first one, it's a 3-channel sampler player. Not really a sampler because you cannot change the samplers, they are baked in when you like make it, because it's based on a microcontroller and the samplers are like literally in the code. But now it has 7 different samplers per channel, and the samplers of course have the sample selection potentiometer and then one for pitch. The pitch goes from -2 octaves to +2 octaves, or quarter of the speed to 4 times the speed. And there's also control voltage in for the pitch, and there's a potentiometer to attenuate the CV signal, so you can have slighter variants. But there's also reverb, which goes quite extreme. There's mix, length or size, and tone, which is basically a low-pass filter on the reverb signal. The length goes almost infinite. You could set it in the code for infinite, but that's a bit excessive even for my taste. But if you want like a rumbling mass of forever, then why not? Then there's also this CV type. Now if I play a sample and play with the pitch knob, when the sample is playing it doesn't change the pitch, but if I put it to the type B, you can change the pitch during the sample is playing. This is for if you want to put control voltage in, basically some random or alpha there. You can have different pitched sample every time, but the sample doesn't change the pitch during when it's playing. It sounds well better if you want just a steady sample, but in different pitches. And of course you can put here other things than drums, but I made this because I wanted tom sounds, and usually like analog generated tom sounds aren't that big, or they don't just like they aren't realistic or massive in a way I like them, so that's why it's Tomboi. But well, that's just the idea. It's like I said, it's made with a microcontroller. Here's a prototype version of it. The yellow one there, it's Electrosmith Daisy, which is, well, like much more powerful than Arduinos usually, except the new 32-bit ones. And yeah, but it's maybe closer to Teensys, but I haven't even actually used them. I have them, but I never used them because this is very good for audio. It says audio inputs and outputs that are high quality, and the Electrosmith gives a good library that has audio library, so you can start developing things quickly. I made the sampler playback engine myself, but the reverb is what default that they have, and it sounds good. Maybe I or someone else, because this is open source, can make a better sounding reverb or options, or technically if you like want the tone even to blend with different reverbs. Well, why not? Yeah, we could maybe check a bit about the schematics and code before going to some demo of this. So here's the schematic of this. It's very simple. There's the daisy seed in the middle, and there's just operational amplifiers zooming the voltage from the potentiometer and from the control voltage in and conditioning it so it's between 0 and 3.3 volts, which is the range that the daisy can accept, and it's actually inverted, so I inverted it back in the code. But that's easy thing to do. Also, the trigger inputs have this kind of Schottky diode protection things. It could have been done with a transistor, but I, for some reason, did like this. Actually, the default code in the daisy expects you to do it with the transistor, which means the polarity is reversed. This doesn't reverse the polarity, but I don't actually know if there's massive differences. Maybe there is, maybe there isn't, but this works, and it's not gonna break anything, and it's compatible with eurorack level standards, so it'll do, I hope. Yeah, and there's also voltage, not regulator, but reference voltage of -10 volts that's used to condition the signal, and I usually put the Schottky diodes to the voltage input just to have it. Well, if you may put the connector wrong way around, nothing happens. With analog electronics, isn't that bad, or actually, many of the operational amplifiers fry if you reverse the voltage, so it's bad there also. But I think especially that this kind of microcontrollers don't like if you give it reversed voltage. So, but it's easy. If you just don't make any mistakes ever, it's gonna be good. So this schematic is in the GitHub repository I have linked, and also a layout for it in the gigart file format. It's open source circuit editor. The printed or PDF version of the layout doesn't really tell you much, but it's basically the front plate, then PCB with the connectors and potentiometers, and another PCB that connects to it with a spike row thingy, and then there's the, well, mostly all the other components. Well, here's the code for it. This C++, there's also other ways to program that daisy. You can take it from the Electrosmith basis, but I like the C++ because it's quite raw. You can optimize things and really know what's happening, but it requires much more skill than some of the others. But it's the world of decisions. I don't know. Anyway, basically, the samplers are C++ arrays. Basically, just code files that have the wave file as an array and a bit of extra things. These don't matter here because, well, they aren't tuned and they don't loop. And yeah, that's just the size. It actually shouldn't be defined, it should be different. Yeah, you can see the code. There's a maybe newer version in the GitHub than what I'm showing here, because every time I check the code, I find something to fix. And this looks funny because polyways and delay and chorus, what are those? Because this is just a simple sample player, because I had a bit of feature creep, and actually I started making a polyphonic synthesizer with effects and full voices and multisampling, like you can have one voice that has multiple samples per octave, so you can, well, it sounds better because you don't need to pitch one sample to multiple octaves. But that is a project for next year, probably, because this makes it a bit more difficult. Anyway, this just basically you load the tom samples to RAM, and why this looks weird is because you need to use like an external RAM than what the processor in the Daisy has, but it's just code fluff things, and there's you have these basically things. You have used the ready reverb, and then there's things that you make buffers for the pitch shifting and delay and chorus and those things that aren't even used here, which maybe should be removed from here. You make toms, make functions for the reverb, and this fast dance is just here to basically make a soft clipping output that if you don't get nasty clipping, you get more nice clipping. This like approximates done function in mathematics, quite crudely, but and then just the main thing you just read and stuff. If you know C++, you probably get what this means. If you don't, I'm not able to explain it to you probably, but yeah. And here's the initiation. You crudely load the things to this kind of sample and voice classes I made, and this maybe could be nicer, but it works. And that's about the code. Let's check what it sounds like. Actually, here is like a prototype of the synth version of this MIDI input, and accidentally reverse place for the Daisy. So, but I called feature because you can access it from here, but it doesn't even boot up. I have some big mistakes in the PCB, so such is life. Well, that was not good. Let's load a better one. That's more like it. But now we are here. Maybe we could patch some more drums here and maybe even effects. Here's the Erika Synth's Pico drums, making probably, I think, what is this bass drum and snare type sound, and here's Logic Tomboi. Let's use that for simpler, like what is called hi-hat percussion sound to make it there. Let's take LFOs there from Erika Synth's actually envelope generator as in LFO mode, and Dreadbox Nostalgia delay which has LFO, and we just use that there too. And here's a mixer. This mixer is actually next project I will probably show, because it's something I designed too, because I needed a mixer for this also. This whole rack is probably or will be a drum rack for if I ever get to perform with a eurorack. Or actually, this will be the only eurorack thing, because I want to use those Cosmo things more, but this getting these drums this way, maybe it's easier. But I'm forgetting the Erika drum thingy. Yeah. And there's big drive. because distortion drums is always nice. And bit of a delay for drums because why not? Yeah, maybe that was enough. Good thing, good way to end because battery of my camera is ending and yeah, goodbye. Next time, more about this mixer. That's much more simpler. Probably, I think. Yeah, there's like not very much components. Bye.